Hello guys, welcome back to another lesson on momentum. Previously we've already discussed what momentum is, and we've discussed what impulse is. And these are the equations for each of those things. Okay, momentum is mass times velocity, and impulse is force times time. Alright, in yesterday's video on impulse, we discussed how impulse is related to momentum, because whenever something has momentum, it has motion, and whenever something that has motion collides with something else, it applies a force over a period of time on whatever it collides with. So during a collision, impulse is applied between those two things that are colliding. Okay, another way to think about how these two are related is that impulse is a change in momentum. So I can write that out like this. Impulse equals a change in momentum. Whenever something collides with another object, it may have some momentum at the beginning, but after the collision, it might lose that momentum. Depending on how the collision happens, it might gain momentum. If it's going slow, then it gets hit by something that's going fast, it might gain momentum. So the impulse is the change in the momentum that occurs in that collision. Okay, I can write each of these things out as they are here, and I get this. Okay, so now I wrote out impulse as force times time, and then change in momentum is going to be the mass times the change in the velocity. In most collisions, the mass doesn't change, so that's why I didn't put a change there, but in some collisions, like in very rare cases, the mass might change. Like let's say something flies off of a car during a collision, and so it'll lose some mass, so it'll have a different mass here too. But generally speaking, this is one way we can make calculations for these variables: force, time, mass, and velocity. Okay, I'm going to go ahead and explain an example now where something has momentum initially, and then it undergoes some impulse. Then we can solve for the total momentum after the collision. Okay, here I have an example of a box of 9 kilograms mass. It's initially just at rest. It has 0 meters per second velocity. Okay, so its initial momentum is going to be 0 because m times v is 0. And let's say I want to know how much momentum it gets after the impulse is applied of 20 newtons over 2 seconds. Well, I know that my impulse is equal to my change in momentum. So if I want to know the total momentum after the impulse, then I just have to calculate the impulse. Okay, so here I've written out my equation again, and I plugged in the force and the time for my impulse. And it says 20 times 2, which of course is just 40. Okay, so I know my change in momentum is equal to my impulse, so it's just 40 kilogram meters per second. Okay, now let's do an example where instead of having something initially at rest, we'll have something moving, and then something's gonna bump into the back of it to speed it up. Okay, so here I have a box of 3 kilograms mass, initially at 1 meter per second velocity. Okay, then this box undergoes an impulse with a force of 7 newtons over 3.5 seconds. Okay, so we're going to see what is the total momentum after this impulse is applied. My total momentum is just going to be the initial momentum plus the change in momentum that is caused from the impulse. So I'm going to write that out here. Total momentum is equal to initial momentum plus change in momentum after the impulse. Okay, I know my initial momentum is this mass times velocity for the initial state, which was whenever it was just going 1 meter per second. So it's just 3 times 1. Okay, this is just going to come out to 3. And then the change in momentum is equal to the impulse. So I'm going to add that. I know that my impulse was caused by this force over this time, so I'm going to go ahead and multiply those two together. Okay, so after I crunch all these numbers together, I find that the total momentum is 27.5 kilogram meters per second. And I should put a direction there too, because momentum is a vector. So I'm going to say to the right. Okay, now I'm going to do one more example where something has some initial velocity to the right, but then the impulse is applied the other direction. Okay, this type of example would be something like a head-on collision in traffic. Okay, let's say I have the same 3 kilogram mass, and now it's going at 5 meters per second to the right. Okay, let's say this mass undergoes a head-on collision where it feels an impulse with a force of 50 newtons for 0.5 seconds. Okay, if I want to find the total momentum after the collision, I would need to do the same equation as I did before. Alright, I know my initial momentum is going to be my mass times my velocity before the collision. I know my change in momentum is going to be my impulse that was applied, so it's going to be 50 times 0.5. But because this impulse is going the opposite direction as the initial momentum, I had to subtract it. Okay, so I'm going to put a minus sign here because it's a negative change in momentum. If it was initially going right and then it feels an impulse to the left, then it's going to be a negative change in momentum. Okay, so here I have 15, 5 times 3 is 15, and then I have 50 times 0.5, which is 25. It's 15 minus 25, which is going to be negative 10. I know my final momentum is going to be negative 10 kilogram meters per second, which means that the momentum shifted from going to the right to going to the left. Okay, so that means that after the collision, it changed directions. If I wanted to find out how fast it was going after the collision, I could also figure that out by saying, well, I know momentum is equal to mass times velocity. Okay, I know the mass didn't change because unless this is a car and something like flew out of it, the mass is going to stay the same. Okay, I drew my triangle here for momentum, and if I want to solve for velocity, it's going to be momentum divided by mass. I found that my momentum was 10 and my mass is 3, so my velocity is going to be negative 10 because it's going to the left, and divided by 3 kilograms. Okay, then I do negative 10 divided by 3 gives me negative 3.3 repeating meters per second. Hope this video helps you guys figure out the Google form, and I also hope it helps you understand the concepts of momentum and impulse and how those two relate to each other. Thank you guys, see you next time.